Hi everyone. In this video, we should learn about the SQL joins and set operations and subqueries. As of now, we have seen what kind of operations and what kind of built-in functions is supported by Oracle SQL. Now we'll learn about the SQL joins and set operations and subquery concepts. So, what kind of joins is supported by SQL? Let me explain here. Okay, here first, we'll go to inner join. What inner join will do if we have table A and table B, whatever the common data in between both tables, it will retrieve the information by using the inner join. If it is contain duplicate data also, inner join will provide the duplicate data information. Okay. Next, left join. What left join will do, whatever the left table data will get completely along with the common records. Whatever the right table data, if we have matched columns, it will print the matched columns. If we don't have any matched columns, that means if we have unmatched columns, simply replace with the null values. Same like right join also. So it will print the complete right table information along with the common records. If we have matched records from left table, it will print. If we don't have matched records, then it will replace with the null values. I'll show you practically. Next, full outer join. So actually Oracle support to full join class also. If we don't have any full join, then simply left outer join and union right outer join will be the full join. Okay, I'll show you practically. Let's get started here. Okay. Next, we have two tables. So one is employee table. We have 14 records in employee table. Okay, here we have 14 records in employee table. Next, department table. We have 4 records in department table. Okay, here we have 4 records in department table. So the common condition should be, if we are trying to perform any kind of the join, we required one common field. For example, so let me explain here. Yeah, department number should be the common field. Here you can see department number from employee table, and here also department table, sorry, in department number from department table. You can see here this relation is explaining about primary key and foreign key relation. In constraints, we have already learned about this primary key and foreign key relation concepts. Okay, here we have common key, department number. How we can perform inner join? Okay, here this is the syntax. Select whatever the fields we should have to use, we can use. Next, from employee table, I'm taking alias E. Next, inner join with the department table on department number. Here, if I am running here, whatever the common data you can see here. So automatically in the employee table, we have 14 records. In 14 records, all values should be matched with the department. So that is the reason you can see 14 records. Okay. So this is the inner join. If we have any kind of the duplicated data also, automatically the duplicate data also will come as part of inner join. Okay. Next, here self join. Second one should be the self join. Okay. So in practically, in which use case we should use self join means, for example, if we want to join with the same table at that moment, we will use the self join use case. For example, in this use case, in company, employee is reporting to one of the manager, and manager also employee to the company. So here in this use case, which manager is I'm sorry, which employee is reporting to which manager, so I want to know the information. Okay, so by using this query, we can easily identify which employee is reporting to which manager. Let me check here. Ford is Ford is reporting to John's. Let me run this employee table. So let me check Ford. Okay, Ford employee number is 7902. Ford is reporting to 7566. Who is 7566? Let me check here. 7566 is John's. Okay, so this self join information will helpful which employee is reporting to which manager. In this use case, I am joining two tables, but two tables are same. Here in our use case, it's employee table only. Okay, this is the self join use case. Next, left join. So just now also I have explained complete left to table information will get, and whatever the matched records from right table will print. If we have unmatched records, so simply it will replace with a null value. So here 14 records, employee table we have 14 records, and department table we have 4 records. Okay, let me run this. The end results will get 14 because left table having 14 records, you can see here. Okay, in this use case, that means employee and department table you cannot see much difference in inner join and left outer join, but in real time you might see a lot of difference. Okay, this is about left join. Same like a right join. So here we have 14. Okay, here we have 4. So the okay, here we have 4. So here, if I am trying to join, here I am using the right join. That means in department, we have 4 fields. Each field should try to join with all the records information. Let me run this. We'll get to 15 records here. You can see here 15 records here. Why 15 records means one of the table information we don't have aligned data with the employee table. Okay, let me show you practically. Select distinct department number. Distinct will give unique records from EMP. I'll show you. We have 10, 20, 30. You can see. But if I am trying to apply same on department table, we have 10, 20, 30, 40. Okay, you can see here. So the 40th department number 40th related data is not available in employee table. That is the reason. So if you are taking right outer join, if I am trying to join with the employee table, you will get one extra record. The extra record is belong to 40th record. Okay, that means 40th department number. That is the reason you will get the 15 rows. Okay, this is the best example between the left join and the right join. Next, union. Just now also I have explained. Okay, left outer join union with the right outer join will give the complete full join information. This is actually a full join, but in Arkill, so we have full outer join class. Okay, we have full join class. Okay, here you can see full outer join class. The same output I can replicate to by using the full outer join. Here you can see 15 records, so null operations. I can replicate the same with the full outer join class. Here you can see same records. Okay, 15 records we can able to replicate. If we don't have any full outer class at that moment, we can use the union with the left join and right join. Apart from this, we have one other join also, Cartesian join or cross join. What cross join or Cartesian join will do? In table level, if we don't have any kind of the common records at that moment, we have to join all the fields information. Okay, so here you can see here we don't have any common join here. Okay, we don't have any join condition. Here I am taking cross join. In cross join or Cartesian join, what will be happen? In table A we have 14 records. In table B we have 4 records. So each record will be joining with the remaining entire records. So it's a very costly operation. That's why you can see 14, 4, 56. it's a multiplication operation here. So it's a very costly operation in production environment. Don't use this cross join, okay? Because in production environment, that means on live data, we have millions of records. So if we are using this cross join, the entire DB will crash automatically because of these operation, okay? It's a costly operation, so try to avoid this cross join in real time. Mostly we have to join with the common fields information only, okay? So this is about to joins concept. Next, subqueries. What is subquery means? So the name itself, it's a subquery is a query inside the query we are calling as a subquery. So here always remember, always the subquery will be executed first, after that only main query will be executed. So in employee table, what is the max salary? 5,000 will be the max salary. We have already known this information, you can see here. Or else let me run this, okay? Select star from emp order by salary DESC. So this will give salary order in descending. That means you can see here 5,000 is the highest salary, next to 3,000, next to 2,975 will be the third highest salary. So what this query will give information, this is the second highest salary by using the subquery concept. So what is the second highest salary? 3,000. First, the main subquery will be executed. This is giving the 5,000. So I am trying to retrieve the data less than 5,000. You can see here, first it will give the 5,000, next it will print less than of 5,000. So it will give the second highest salary information by using the subquery. If you want to print third highest salary, same, you can copy paste same information and you can use here. It will give the third highest salary. 2,975 will be the third highest salary. You can see here. Yeah, we have duplicate data, we can ignore that, okay? 5,000 is the first highest salary, 3,000 will be the second highest salary, next to 2,975 will be the third highest salary. So by using this subquery concept, we can able to identify this query will be helpful for finding third highest salary by using the subquery concept. So always remember, it will execute the subquery first, after that only main query will be executed, okay? Next, one more thing. So subquery we can use either in where class or we can use after from class. Here you can see this is also same. I am trying to identify top salaries, okay? 5,000 will be the highest salary. Here I am using the row name, that is the reason you can get up to here 5,000, 3,000, 3,000, okay? So either you can subquery concept after the where class. Here you can see in this use case I am using after the where class, or else you can use after the from class, okay? If you are using after the from class also, this is considering as a table only, okay, as b or whatever it is. So if you run, yeah, sorry, this is okay. So after the from class also, it will consider as table only, you can see here. So we can use either in where class or in from class, okay? So yeah, this is about to complete table information. So apart from this, we'll learn about the set operations. Set operations are mostly for mathematical operations. In SQL level, what kind of set operations will be supported? Let me explain here in Oracle level. Okay, I have created three tables. One is employee and department table. So here I have one, two, three records, and next I have created employee department 2, 3, 4. Here you can see what is the common data. 2, 3 records are the common data here. why I have created common data, I'll show you. Okay, how many set operations will support? Let me explain here. First union, next union all, next intersect, last one will be the minus. Okay, so in RK level we have supported four set operations. Let me explain one by one what union will do. Okay, in table A and table B. So before performing any kind of this set operation, must and should the metadata should be matched properly. If we don't have metadata matched condition, automatically it will fail. Okay, I'll show you practically. Okay, so let me show you. So in each table, either department, employee department, I have created employee ID, employee name and department only. As of now I have created only three fields. If I have given additional field, if I am trying to apply any set operation, this will fail. You can see here practically, you can see. Okay, the number of resulted column is not matching, so this is the mandatory condition before applying any kind of the set operation. Okay, this is the fundamental rule for applying the set operations on table level. Metadata should match mandatory. If table A, if you are using the employee ID or any other field in table B also, you should have to use the same metadata matched information. If metadata is not matching, then the results will be failure. Okay, this is about set operations, the basic fundamental rule of set operations. Next, let me run this union. What union will do? It will club both tables information and does not allow duplicate values. Here you can see 2 comma 3 will be the duplicate values. There is no 2 comma 3. Again, the duplicate data is not available. From table A, you can see individually I can run and I'll show you. 1 2 3, 1 2 3. Next, table B, you can see 2 3 4. If I am trying to run the entire query union, what union will do? It will club both the tables information, but it does not contain duplicate data. You can see here it does not allow duplicate data. This is about union. What union all will do? It will club the entire results information along with the duplicates data. I'll show you here. You can see here 2 3 repeated and here also 2 3 repeated. This is duplicated data. In union the duplicate data will not allow, but in union all the duplicates also will be allowed here. Next, intersect. What intersect will do? It will print common records. Okay, let me run this. So here 2 3 will be the common records, so the only common records only it will show here. You can see intersect. Next, minus. What minus will do? And here also one more thing you can remember. So whatever the table information you have used to, that is very important. Okay, whatever the preceding table information you have used to, the results also depending on the table information. I'll run this. You can see simply it's a minus b. I'll show you why a minus b means. Here I have taken, this is the a table and this is the b table. I am doing a minus b. So whatever the common data, 2 comma 3 will be the common data, so the common data will be excluded, that means removed. After that, what is the result you have here? Only one. So you can see the one only, the end result. This is about a minus b, because here 1 2 3 2 3 will be the common data. So if you exclude the common data, whatever the end result only, you can see here the end output. So if you are using the reverse, b minus a, whatever the preceding table you have used, the end results also depending on the same. Okay, let me see here. I am using this is as a preceding table. That means you can see department 2. In department 2, you have 2 3 4. If you exclude the common data 2 comma 3, what is the remaining data? Only 4. Okay, you can see here the end result is 4. So while using minus operator, so whatever the preceding table you are using, the end result is purely depending on the preceding table. This is about to set operations. We have 4 set operations. So first one will be the union and union all, intersector and minus. Okay, the basic condition for performing any kind of the set operation is metadata should match mandatory. If metadata is not matching, then how we can perform set operations? I'll show here. Okay, if we don't have matched use case, for example, here you can see we don't have any matched use case at that moment. So whatever the extra field you are trying to add, you can add null value at, I mean, in table B. You can see here. Let me run this. So you can use the null value. Got it? So based on that, we can perform set operations. So that's all about this video, guys. Thank you.